All right, so I had to make a part two. This is going to be a very short part, so don't freak out. It'll be really quick. So, adding on transport. So, tall smokestacks will allow the industry to meet local air pollution guidelines. You'll see these smokestacks in industrial areas. And so, moving on, sulfur, a lot of the times it's called SOx, and that like NOx, it's SOx. This is going to be where electric power companies burn coal are a major source for sulfur oxides. And then smelting of metals like copper, zinc, lead, and nickel will produce a lot of sulfur dioxide. And then NOx, again, it's, hold on. So at normal temperatures, the oxygen and the nitrogen gases do not react with each other. But when temperatures get hotter, the nitrogen and the oxygen will form nitric oxide. These are going to be found in coal and oil combustion through electric power companies and also during gasoline combustion in automobiles. So acid deposition is going to be a big problem in major coal burning power and industrial plant areas. And you can stop and look at this picture to get a better idea. And sorry. So in your notes, you're going to need to write down the acid deposition, a problem, analyzing it, and write down where is it exactly a problem. In the ecological effects, you're going to stop and analyze what this graph shows and how the different organisms are affected by acid deposition. Okay, aquatic ecosystems. Acid rain affects your bodies of water a lot of the time in watersheds because there's a limited availability to, or hold on, a limited ability to neutralize acidic compounds. And in areas where the buffering capacity is low, acid rain also releases aluminum from soils into your lakes and streams. 30% of the nitrogen in Chesapeake Bay comes from atmospheric deposition, which is a big problem with our fish and our organisms that live there. Terrestrial ecosystems, there's a lot of leaf damage due to acid rain, so there's a lot of damage to forests. And acid deposition reacts chemically with the forest soils. They leach away all the nutrients vital for tree growth, while at the same time mobilizing toxic metals into the soil. This is an example of needle damage in a black forest. We have damage here. This is a healthy leaf. And this is acid deposition on a structure like a statue. This is what it should look like. This is what the acid is doing to the structure. So man-made structures, acid deposition will damage your limestone, your marble, and your sandstone. So things like houses and structures and other things. It also affects your metals, your paints, your textiles, and your ceramics. So several factors that can decrease or increase outdoor air pollution. Factors that can increase: urban buildings slow wind speed and reduce dilution. Hills and mountains reduce airflow, and valleys below them, this is where pollutants will build up at ground level. High temperatures promote chemical reactions. Grasshopper effect occurs when pollutants are transported at high altitudes by evaporation and winds from tropical and temperature areas through the atmosphere to polar areas. And then temperature inversion. This is where a layer of warm air temporarily lies atop a layer of cooled air and traps pollutants. This is a big thing to know. If you need to really remember anything from one slide, this is the thing you need to know from this slide. Temperature inversion is a big deal in the AP exam. 5 natural factors to reduce outdoor air pollution. Particles heavier than the air settle out. Rain and snow partially cleanse the air. Salty sea spray washes out many pollutants from air that flows from land over oceans. Winds will sweep pollutants away and mix with clean air, which is dilution, and some pollutants removed from air by chemical reactions. So you need to stop this video and draw what a thermal inversion is. Remember, this is very important to know. This is where warm air will basically blanket a cold air layer, and it'll trap the pollutants in there. Urban heat island effect. Urban areas are going to be hotter than rural areas. This is going to be where the temperature is higher, with the annual mean of the air temperature of a city with 1 million people or more can be 1.8 to 5.4 degrees Fahrenheit warmer than the surroundings. This causes because buildings will block the surface heat from radiating into relatively cold night sky, changes in the thermal properties of surface materials, concrete and asphalt, and a lack of evapotranspiration in urban areas. Indoor air pollutants, so they're going to be greater than the outdoor air pollution. You're going to see asbestos. This is in pipe, insulation, floor tiles. Causes are going to be lung disease and cancer. Formaldehyde, furniture stuffing, foam insulation, particle board. The causes are going to be irritation of eyes, throat, skin, lungs, and it's going to create dizziness and nausea. Radon 222, naturally occurring colorless and odorless radioactive gas found in soil and rock that can seep into homes and buildings, can cause lung cancer, seal cracks in foundation and vent basement. Then you have carbon monoxide, respiratory system, works as a natural defense, and then also sick building syndrome, where the building literally makes you sick. So you're going to stop this video and fill out that chart that's on page 24. And that's it for the notes of this unit.